So, welcome to our repeated VLSI training and placement program. So, which we basically going to start our new DFT batch from next week. So, that is one of the reason why we have started our we are planning for our DFT demo today. So, we are delighted to have each and every one of you here today as we embark on a journey of learning and growth. As you know, the learning plays an vital role in current to start the careers. So during this session, we aim to provide you with a comprehensive overview of what is VLSI, why the VLSI training is required, and what would be the DFT, what is the career growth, and everything will cover. So highlighting its objective methodologies and the valuable skills you will acquire, it is our sincere hope that this demo session will give you a glimpse into the exciting opportunities that basically you are looking out for. As you know how you can look it out how the semiconductor industry is booming, and even in our Indian government also investing a more amount on the semiconductor industry. That is really good news for us. Okay, so this demo session serves as a platform for everyone to experience the unique blend of expertise and innovation that our training and placement program offers. So it is an opportunity for you to ask questions. So now I would like to introduce our trainer and our CTO, Mr. Kumar. Hi, Kumar.
Hi, Yusuf. Hi,
Yeah.
everyone.
So I just wanted to give some introduction about Kumar. So Kumar is having around 12 years of work experience into VLSI DFT. Okay, he is engaged with many product-based companies. So he's currently working with one of the MNC product-based company as an tech lead. Okay, yeah. So I would request Kumar to please go ahead with the further session. So guys, I would request everyone to please be make yourself on mute. So if whenever you have any queries, please make a note. So end of the session, we'll have an Q&A session where you can ask your queries and all. I wanted this session to be very much interactive. So what are the queries you have with respect to your technical perspective or any career growth or anything which related to like in VLSI semiconductor industry? We are happy to help you guys. Yeah, Kumar, please go ahead.
Thanks, Yusuf. Okay, so welcome to the session, guys. Good morning, everyone. So I think my introduction is already done. I don't want to repeat it again for you. So I'll come straight to the technical presentation here. I'm going to help everyone today on the platform uh, who want to enter into semiconductor, who want to make their career into semiconductors, or you can also call as a VLSI domain. Okay, so for them I'm going to help what is the current working nature of semiconductor, what is the working domains, and what is the role of DFT particularly in the semiconductor chip designing. Okay, let me share my screen.
Guys, in the meanwhile, so there is an Google link which was shared in the message box. So I would request everyone to fill that form so that our any updates regarding our training and that will be updated to you. So that please ensure to fill that Google form, please.
Okay, so I hope everyone is able to see my screen.
Yeah, Kumar, your screen is visible.
Okay, right. So we are going to have an awareness on semiconductor today. and the differentiation between software and semiconductor salaries and packages, and the scope of chip designing and future fabrication technologies. Okay, and what is the differentiation that you get mostly from academic to the real-time differences, and what is needed to be part of semiconductor in real time. Okay, and the training course syllabus duration and all will be discussed, and we'll also discuss what would be the prerequisites and EDA tool experience that needed for training and for the placement. Okay, so here you can see that VLSI uh, is one of the fabrication methodologies, unlike uh, the embedded manufacturing. First, we need to integrate and design a chip, then we can go ahead program it as per our need, which is embedded systems. So in a VLSA, where we are trying to design the chip. Okay, so VLS is one of the methodologies. After VLSA, we have currently we are using three-dimensional, two-dimensional ICs, and much more advanced technologies in the integration. And we are currently at uh, one 1 nanometer. Okay, currently many of the companies, even the company that I'm working, uh, they are uh, working together. All the engineers and senior people are working together to bring up new test methodologies onto the latest technology nodes. Okay, so DFT, the name itself is a design for test, and it plays a very crucial role in the semiconductor industry. We are going to see how DFT works in the real time, and what is the uh, issues faced without DFT, and how DFT is going to fix all those issues and overcome the challenges faced by the semiconductor industry. Okay, and we are going to see the future trends in DFT, how it is going to uh, make impact in providing you the end users in terms of laptop, mobiles, or any electronic gadgets with high endurance, uh, longevity, and refurbishable, diagnosable. All these features comes out of DFT that we are going to discuss, and we'll have our Q&A discussion end of the session. So here I have around 12 plus of years of experience with working in top MNCs in semiconductor. I work for most of the time for Intel, microelectronics, even in India and Malaysia. And I have worked for different customers, Renesas and Alchip, TSMC, and NVIDIA. And there are many other clients that I work for. Okay, so I have seen many ICs getting manufactured. I was part of the design, and I have seen all the challenges that uh, current semiconductor is facing. So we are going to uh, discuss that end of the session. Okay. So to be very clear on the DFT and to help you understand what DFT does in a very short uh, explanation is DFT is going to give the IC post after manufacturing. Okay, during manufacturing, after manufacturing, DFT is going to help identify the faults or the issues, the manufacturing issues. Okay, and post manufacturing also, once the IC gets shipped into and it is on the in the hands of customer, like you have purchased your mobile phone, it may be Apple, Samsung, MI, any phone. or a Lenovo laptop, a Lenovo or a HP, any of the laptops that you are seeing. Once you have an issue that the motherboard is heating up or your PC is heating up, your certain hardware is not functioning well after purchase, then you go back to the seller and he takes the device and he will say that within the warranty period he is going to send this to the manufacturer. Okay, then if it is repairable, he is going to refurbish and give it back to you. Okay, so refurbishing means he is going to remove the faulty IC within your motherboard. That there is a big PCB board. On that there are multiple individual ICs that are playing its own individual role, like CPU, RAM, ROM, sensors, all the peripherals. Okay, analog and digital. Now all of these needs to be first tested. So whether it is really at fault, which one is at fault, we should be able to diagnose. Okay, that diagnosis feature. How do you test? How do you know that this particular IC, out of all these multiple ICs on the board, are failing? Okay, that also can be detected using board test, but not just board test. You can also help go inside the IC and check which part of the module is causing this issue, which will help the next generation of ICs to be less faulty. Okay, so we'll fix it in the next version of the IC that is getting manufactured. So all that needs some diagnosis feature, the DFT feature. Okay, which can tell that okay, this particular AND gate, NOR gate, okay, input or outputs of these gates are tied low, tied high, not connected to the previous gate. Okay, all these issues will be identified using DFT feature. So DFT literally gives you the diagnosis feature, refurbishable, okay, and reusable, which are very important to reduce the IC scrap. So it's not like use and throw IC. Once you use it, just throw it. So IC wastage has been recyclable, is now recyclable because they are going to extract the working parts even after you are throwing your mobile phones or laptops once you're done. So
Kumar, you're on mute, I think.
okay, am I audible now?
Yeah, yeah.
Okay. Okay. So IC has the input and output pins, bidirectional and bidirectional pins as well. So post manufacturing, an IC has to be verified by providing inputs and expected output, because you already know the design or the equipment or the machine already is configured to test this particular IC, knowing that okay, you give this particular input and this is the expected outcome. So stimuli and response will be checked, and we already configured the testing platform with the design, so it already creates an expected response outcome of this particular IC for a given input. Okay, so let's say there is an AND gate. AND gate inputs, when both inputs are high, then the expected output is high. So this information is already known because our compilers have this all the truth table behaviors of the all the logical gates and sequential elements. Okay, so the same will be provided to the tester, automatic test equipment, and it is going to compare, and expected response is what we are seeing. Once we provide stimuli, then it is good IC. If not, it is a bad IC. So the test development is generally is done by verification engineers and DFT engineers. So verification engineers can only give functional, only can verify the functionality of the design. That means there is this AND gate, or there is a half adder, full adder, or any adders or multiplexers or all the combination logic circuits that we design for this ALU, arithmetic logic unit. Okay, that logic behavior will be verified by the verification engineer. DFT has a completely different purpose, where he is going to go inside of each and every module, each and every logical gate. Input and output of logical gates can be controllable and observable. That is the role of DFT. So verification engineer only can give input to the primary inputs of that particular module, and he can check it the output only. He cannot check what is happening internally. Even if internally something is wrong, but you're still getting expected outcome, that's possible. Okay, so because of that, there are many expected manufacturing defects post IC handover to the manufacturing team. Okay, everybody has designed it, designed the IC, given it to the manufacturer to manufacture. Then manufacturers will do first initial testing. If it passes and he confirms that okay, this particular design, if you go with the mass manufacturing of 1 lakh or 10 millions or billions of ICs at a time, this is the number of ICs you can expect, good ICs, and this is the number of bad ICs you can expect out of this design, existing design. That mechanism we have. Okay, so that is called yield. 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 Yield is very important. Okay, so out of,
Kumar, sorry
yes,
to interrupt. So we are the same presentation stimuli responses. Is the same one?
yes,
Okay.
correct, yes. So out of 1 lakh or 10 lakh mobiles that the manufacturer is trying to manufacture at a time, okay, uh, you can't expect all of them to perform as expected by end of the manufacturing. That is the case in semiconductor because of many issues. Mostly are functional issues, the design issues. The second is the manufacturing fabrication unit has some issues. Okay, the manufacturing equipment has issues. So we want to reduce, what we can do at our end is as a design engineer, we want to reduce the functionality issues, the design issues, because we don't go to the fabrication unit and work there. Okay, we are design engineers. We make sure that this our design is going to be a good IC once we give to the manufacturer, making sure the functionality is completely 100% tested, close to 100%, not 100%. Okay, so as an example, you can see this is a chip with logical gates inside is, and you separate logical gates with the sequential elements for easy understanding. These are flip-flops. Okay, these are logical gates. So general verification engineer, a design verification engineer, it is also one of the working domains in semiconductor. He is going to write a test bench by providing inputs as a stimuli and check the outputs. So he doesn't care about what is happening inside. Okay, so This is a verification engineer's role. And whereas DFT engineer's role, I'm explaining the two domains just for a clear understanding. Okay. DFT engineer is going to convert all these flip-flops in the existing design, okay, into a test a DFT architecture flip-flops. Those are called scannable flip-flops. Okay, that mechanism and all you can learn later in the course. So these flip-flops will help you, okay, to go and already these are connected to the logical gate inputs or outputs, correct? So you can control this particular flop to load our desired value. Okay, so logical gate can be tested for 0 or the 1 as per this truth table behavior. So that controllability deep into the IC at each and every logical gate, DFT is going to insert this additional DFT mechanism. Okay. So these are all the different roles and stages of IC, starting with the proposal of IC design and till going to the customer, starting with let's say now MI or MI means Xiaomi or you can take OnePlus, Oppo, any other company is coming to AMD or any IC designer, okay, and manufacturer also. Like Intel is a designer as well as manufacturer. Samsung is both designer and manufacturer. Okay, likewise. And TSMC is both designer and manufacturer. So we'll see the differentiations later. Okay. So once they come and say, I have a proposal that I want this kind of IC for my next mobile chipset with these advanced features. I'm competing with all these vendors, competitors in the market. So I'm bringing up these features. Okay, can you implement this? This is the criteria the client or the customer brings in to the designer. So the designer will start discussing and he comes to a conclusion that what can be done and what cannot be. And both on the both agreement, what can be done and how much duration it needs to design this particular IC proposal. Okay. Then they start giving it to the RTL design engineers. So RTL design engineers are the first engineers who will start writing the code for using Verilog or VHDL. Okay. So when he start, when the customer says this particular IC, then your mobile chipset has many parts: display, memory, in terms of RAM and ROM, CPU, your processor. Which processor you want to go? You want to go with Qualcomm Snapdragon, or you want to go with different processor? Okay, so all of this. Xiaomi is just a mobile company name. Not, he is not a individual. I'm going to show you that. Okay. So each company will is expertise in designing a particular part. So you are going to go with go and purchase all of these IPs, and you are bringing it to the designer. Now the designer is going to take up your project and will give you deadlines, and he's going to provide you quarterly or monthly updates that this is a stage where we are, and within this duration we are going to finish the project and give it to you. Okay. So after RTL has been designed for each of the modules, okay, then logical verification, synthesis, timing verification, and all this will happen. Okay, this is all front end. This all comes under front end. RTL designed to still until placement and routing, everything comes under front end. Okay, back end is where physical design engineers will do placement routing, LVS, DSS checks, post layout, timing verification, layout, and after layout, then it will go on to the manufacturer. That is called fabrication stage. It goes to the foundry. Okay. So after foundry, after IC got manufactured, it converts into individual chips and chip will be verified again and it will be packaged and it will go to the customer. Okay. So converting this particular flowchart into this easy understanding, this stage, design for test. We are both the front end as well as the back end because DFT will play a crucial role after RTL has designed and given to DFT. DFT is going to add additional logic, the DFT logic, using the tools. Okay, and once the test methodology is inserted in the design on the existing RTL design, okay, it will be given to the designers. They will do flow planning, all of these stages. Okay. So this is another board, as you can see. This is your RISC-V processor SoC, the polar SoC. Other than this, there are many analog components on the board, and there are some digital ICs, sensors. Okay, GPIO. This is a programs. GPIO is a vector. Okay, where your primary input and output of this, which will be connected to each and every component here. Okay, so this is the outer picture, which we don't care actually. We, as a DFT engineer, we don't bother about what is happening on the PCB. Okay, because we will be designing this one. We are not for analog. We are digital design engineers. So digitally, what we will do is we will try to design this particular SoC where you will have all the digital components. Okay, so your cores of your CPU, graphics, all these are RTL code written. So you are going to test it, digital testing. Okay, and Intel, Samsung, TSMC, Global Foundries, SMIC, EMC. These are all the global foundry players. That means only these companies have foundries. Okay, foundry means who can convert your design into an IC. Okay, he has a fabrication unit. TSMC, Global Foundries, SMIC, EMC. So, in 2016-22, you can see a very change of technology. Okay, to reach to 14 nanometer, it really took 20 years. Did not take the picture of 2006, but in 2006 we are at 180 nanometer. Okay? By 14 nanometer, again, we are at 1 nanometer. Few companies already started 1 nanometer. So there is a uh, drastic change or fast phase in semiconductor, also because of the engineers who are contributing and helping, so that we are bringing advanced technologies, so that we are using it lives in terms of smart televisions, smart gadgets. Okay, your even the cars are having convenient smart infotainment systems, and your mobiles are smarter enough to support AI features, artificial intelligence features. Okay, and televisions are smart TVs, gaming consoles. Okay, all of them.
Hello, sir.
Yes.
Sir, your voice is breaking.
Am I audible? Am I audible?
Your voice is audible, Kumar, but there is some gap in between. It was getting stuck.
How long? Since how long you're facing this? You're seeing
On
this?
the it was a previous 13 slide, I think.
Okay. 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 So I was explaining about these foundries, where they started their journey into the technology node and where they came now. They are at a 1 nanometer technology. Okay. So moving on to the future scope of chip design engineer. As you know, AI is the latest uh, technology that we are seeing, artificial intelligence and machine learning. For that, to support AI and machine learning, the hardware is so complex, because I have worked on two AI processors already. Okay, AI chipsets, which are going to come into market next January. Okay, I'm working for Intel and different NVIDIA clients. Okay, so uh, what we are seeing is a bigger designs. The designs are keep increasing a lot, because we are trying to reduce the size of the transistor, and we are trying to bring more features into design. It's not like transistor size is getting reduced, that means your IC size is getting reduced. No, we are trying to reduce the transistor size, and we are trying to bring more and more complex designs. Okay, so when your IC size got shrinked, your EDA tools that are supporting us has to be smarter enough. Engineers has to be smarter enough to do all of this again. Okay, so likewise, we need lot of engineers dealing with more complex designs, because end of the day, you are not going to do it on your own. None of the domains that I have shown you are going to do it on their own. EDA tools are going to do it, and your engineers, the semiconductor engineers in every domain, are going to monitor the tools, use the tools to perform the chip manufacturing, chip designing and manufacturing. Okay, it is manufacturing has machines, designing has tools. 80% of the work is done by the tools. 80%. Even RTL design engineer uses tool to write the RTL code, and most of the times RTL is already there. A previous version is there. You just add new feature into it, so you will reuse the existing SOC. Let's say ARM versions. There are many versions of ARM. Your previous version is already there. On the top of that, you are going to add new features. If you are going to do Qualcomm, Snapdragon is already there for many years. It already has a code. We are going to add new features. So the engineer's work is to learn how to utilize the tools, how to control the tools, to implement this uh, chip designing of complex and different end products. Television IC is a different end product. Okay, military, medical applications, mobile SoC, laptop, all are different end products. Okay, so all of them have different
sensors, different elements on your board. Okay, so it's more interesting to learn how they work. As a theoretical part, what you are going to learn is how the IC is going to get manufactured using this particular methodology. How RTL design is going to be, how verification engineer, how DFT is going to be implemented. That theory you have to learn, as well as what is the DFT tools that we use to perform this. We are going to practically work on the lab, okay, in the institution, and you are going to learn how the tool performs DFT, so that you are ready to directly be onboarded into any semiconductor company and work on a project. Because one biggest reason and the challenge is here, semiconductor companies don't spend time in training you again. That means they hire you as a fresher, and they train you. There is a dedicated trainer for you to train and all of this. We don't have that. Nothing as such. Okay. The reason training institutes exist is training institutes provide you the same tools that real-time engineering tools that you use for designing any product. You are going to learn that tool, learn the methodology that they are going to use, how tool is going to function. All of that you are going to learn in the institution in the particular 3 months or 6 months of course, and you are going to get go for interviews, okay, for any of the company, semiconductor company, and they are going to directly ask you about how you are going to do this DFT implementation, okay, and what is the tool used, what are the commands used, how tool behaves. All of these questions, if you understand and you are going to explain it to the interviewer, then you get a job. And once you get a job, as you already trained on the tool, you will be a junior or a basic initial first designation of DFT engineer, and you will start learning on a real-time projects, working along with your seniors. Okay. So there are many what we call uh, advanced techniques that we are coming. IoT is already there in the market. Quantum computing is revolutioning as of now. Many countries are working on it. So any technology they are trying to bring, or anything that is something in the market that you heard about, okay, NVIDIA is now built a big AI chipset. Okay, that chipset you have to design. Okay, and once you an engineer is going to contribute in designing it, then only you can bring it to the market. Okay, so engineers are needed for all this technology to come up, either it is a quantum computing or UV or whatever. Okay, so you guys are needed. Okay, so on a close zoom into DFT, I'm going to help you with what we call the abstract view of DFT, where is a process of designing integrated circuits with built-in test structures that help to improve the testability of the ICs during manufacturing and post-manufacturing also. This includes the insertion of test structures and circuitry that can be used to test and validate the functionality of the ICs during the manufacturing process. Okay, it has the benefit of manufacturing. You used established replaceable of ICs. Okay, all this is DF, and it is an
Sir,
important part.
your voice is not audible, sir.
Okay, am I audible now?
Yes, sir.
Okay. Okay, so DFT is an important process because all the manufacturers have complained that the after the design is going to manufacturing, when they start uh, bulk production of ICs, that means manufacturing, they are seeing more bad ICs. than less and less good ICs. So that's a huge loss for the manufacturers. Okay, so to avoid that lot of money loss for the manufacturers, and engineers, like many engineers who has contributed into design for test features, okay, they gave the confidence to the manufacturers that the techniques or structure, the test structures that we are going to integrate into the design will help identify any kind of manufacturing issues during the process of manufacturing and post manufacturing also. Okay, which will reduce the bad IC count. Okay, so this improves the reliability and quality of the ICs and reduces the risk of defects and failures. Okay, so there are many, not many, I would say three different stages in DFT. One is scan chain insertion and testing, boundary scan testing, built-in self-test mechanism. Okay, these are the things that you will be learning. And for memories like RAM, ROM, there is separate testing, memory testing. Okay, and for analog and mixed signal testing, there is a separate thing. Okay, so all of this will be done during the process of designing an IC. As I said, DFT falls after the RTL design engineer. DFT is going to take that RTL and test that RTL and insert the DFT logic. Okay, any Q&A? Please shoot out.
Yes, sir. Good morning, sir.
Yes, Rakesh.
Am I audible, sir?
Yes, Rakesh. You are audible. Yes.
Yes, sir. Actually, my doubt is that we are testing the physical IC, or like in the design process we are testing the IC.
This is not PCB testing. As I said, we are not going to be part of any of the post-manufacturing testing. We are going to do it during design stage. Okay, on your laptops
Okay.
using the tools.
Okay. Sir. Okay, sir.
Right. Regarding the course structure and course fee, everything will be discussed by Yusuf. Okay, or technical questions if you have, please shoot out. I'm going to help you explain what is there in this training process, or what are you going to learn, what are the job opportunities and all. You can ask me.
Sir, how will be the future
Sir,
of
I have.
the
One by one.
Hi, sir.
Uh,
Sir, I have a
yes,
hello?
small doubt, sir. Sir,
yes,
we
Manan.
testing the chip, sir. Sir, there are a million of the chances are there, sir. How are testing that? This is difficult task for testing that one.
That's what the tool does the part. We have mentor graphics tools, Cadence, Synopsys. Okay, in the industry, they use EDA tools. These are called EDA tools, which will do
Okay,
the
sir.
analysis of the design. We give the input to the, let's say, uh, there is a mentor graphic tool or a Synopsys tool for DFT. Input for the tool is the RTL design, the very low code. You give it, tool will do analysis. Okay, and we tell the tool to check for the any issues existing in the design functionally. Okay, and we tell the tool add this particular additional circuitry, so it will add. Everything is done by the tool.
Okay, sir.
You as an engineer, DFT engineer, learn how to implement it and how tool does that. Okay, so you can
Oh,
guide the tool, because in industry we are not going to trust the tool blindly. We did not come to that stage. Okay, We are not going to trust the tool. We are going to use the tool to perform these activities. Tool is just a platform. Okay, in academics, you might have seen CAD labs or Xilinx, Model Sim, or like these tools you might have seen, right? Digital labs. Likewise, in real
Yes, sir.
time, we use
We use the Vivado.
yes, correct. So in real time, we use Synopsys or Cadence or Mentor Graphics or combined as well. Okay,
Okay, sir.
right. Yeah.
Hello, sir.
Yes. Yes, Savalkar. Tell me.
Sir, I have one doubt, sir. If, sir, while
Yes.
testing the design part, if we found out some of the bugs, means that time we
Yes.
can debug that issues, or that tool only we need to give the command for a tool. A tool only we means
So,
that resolve that problem, or we need to resolve it.
as a DFT engineer, the role will be we are taking the RTL design and we are going to check for the functional issues as well as what we need to insert. We already know that what is the role of DFT. Okay, we already have a circuitry of DFT that needs to be inserted. For inserting this, ask the tool to check for the existing issues of the design. First, we'll check if issues are there, then we'll directly give to the RTL design engineer back and we'll tell him to fix it if there is any functional issues. We don't care about any functional issues. Okay, we give back to the
Okay,
RTL
okay,
design
sir.
engineer. RTL design engineer is going to correct that particular code. Okay, there will be very
Okay.
minor. Okay, uh, because the engineers are already efficient in doing that process. So even verification engineers are going to verify that RTL code. So you will not get much of an issues. So as a DFT engineer, while inserting DFT circuitry, we will have some hiccups. Okay, and we are going to manually fix them, or we tool has a feasibility of auto fix. Both are there. Okay, tool can do
Okay.
auto
Yes, sir.
fix, or you can do manual fix. So let us
Okay,
say
sir.
that few companies will say uh, AutoFix is going to create lot of circuitry. Okay, because you have 1 lakh issues. Tool is going to create 1 lakh gates to control that issues. Okay, so
Okay.
certain companies will
Yes.
say, well, let's
Yes.
not go with automation. Your engineer has to fix it. So engineer will write a small script with the tool commands. Okay, to fix the issues
Yes.
at the root cause instead of going with every gate. Okay, you will find the root cause and you will fix there, so all the cascading logical connections all will be fixed. Okay,
Yes, sir.
this will be taught in
Yes.
the course. You will learn all of
Okay,
this
sir. Okay. Yes.
in the course, right? Thanks.
Yes, sir. Thank you.
And uh, let me see if somebody has questions in the group chart. So what are the subjects that help to learn this DFT? There is no DFT subject. I think going forward in the colleges or universities, they are going to implement it. But as of now, there is no DFT subject in the academics. Okay. DFT has to be learned from the course institutions they provide, as we are providing. SuccessBridge is providing DFT course, and this is the demo session for that. We have an ongoing batch. For that, we are going to take up the candidates who are interested, and we are going to train them and support them till they get placed in the companies. Yes, Naganuri, Shivu, yeah, please ask. You have raised a question. Yeah, you raised your hand, right? Please unmute and ask if you have any questions. Rakesh, you want to ask?
Yes, sir.
Yes. Go ahead.
Sir, how will be the future of DFT engineers, sir, in terms of package?
Okay, the package discussion and all, again, Yusuf is going to explain. Okay. but let me give you a little brief. Okay. Uh, so semiconductor is most wanted at the moment. Okay, software are already uh, in every college outcomes, everybody tries to go into software as a basic level. Companies will come, even the small company or big company, they try to go into software. Semiconductor is something that EC, triple E background people are more interested, as this is a core company, core domain. Okay, and this is not hardware job. This is a software where you learn. You already know very low coding. Yes. Uh, Rakesh, am I audible?
Sir, like, yes, sir.
Hmm.
Sir, like with respect to PD and DV role, I'm asking
Yeah,
how it will be
I'm
with
trying to
DFT.
elaborate your question and answer because there are multiple audience here. If they might also have the same question, I'm trying to explain
Yes, sir.
in generic to everyone. So uh, the openings are great in DFT. There will always be openings in semiconductor, irrespective of the domain. Okay, for DFT, you will have every year you will have DFT openings. DV sometimes there could be less in a particular year. Sometimes there could be more. Physical design also depends on the need, but DFT is always needed because you need more engineers to test the design. Okay, and insert the
Okay, sir.
testing method. Okay, and it is the DFT is also highly paid, similar to the highest paying domain in semiconductor is physical design and DFT, also verification engineer actually. Okay, I think the left out one is the RTL design engineer. RTL design engineer is less paid because even academic outcome can write a very low code. So in a way, so what the pay is less for RTL design engineers. And RTL design in the future can be automated. That means you ask the AI to write a code, it can write because you already the compilers know the truth tables of each and every logical gates and sequential elements. Correct.
Yes, sir.
So the second stages you have to be there, starting with the DFT, physical design, analog layout, post silicon. There are many other designations. All will be eternal. I think they will always be there. Okay.
Okay,
Salaries are
sir.
great. As a fresher, you are starting with as a fresher, the salary of software or hardware or semiconductor is all same. 3 lakh,
Yes,
4
sir.
lakh, 5 lakh, 6 lakh. Okay.
Okay, sir.
Okay.
So are there companies in Hyderabad that are tied up with the institute, sir? Like for placement purpose?
Placement purposes, we have a lot of companies within India and outside India also. We have types. Okay. So in Hyderabad, we have Cient, okay, and all the service-based companies existing in Hyderabad and in Bangalore also. Our entire semiconductor is within these two, and as well as Chennai, Vizag now, okay, in Noida. So we have tied up with companies, not with the particular location specific, because they already have branches everywhere. So you can always switch accordingly.
Okay.
Let's say Cerium, if you are
Okay,
taking
sir.
this Cerium, they have their branch in Vizag, they have their branch in Hyderabad, Bangalore, Noida, everywhere. So HCL has everywhere, Wipro has everywhere. Like, okay.
Okay, sir.
Yes,
Sir, hello.
right.
Yeah, okay, still.
Sir, can I know about like work-life balance in DFT?
Work-life balance. DFT.
Like I know,
Is good.
so like I know I have seniors in the PD domain. They are saying that in the PD domain there is no work-life balance and
True. Physical design, as you can see, I have shown you previously, right? The stages within physical design are many. You have to do synthesis.
yes,
You have to do uh, placement and routing. Okay, you have to do layout. There are many stages. So
yeah,
they have to sit till the tool shows the results. Okay, you ask the tool
yes,
to run
sir.
something, right? It will take certain time. You have to wait for it. Then you
Yes,
have to check for any issues. Again, you have to rerun. For that, no, engineer has to keep his laptop beside. Work-life balance is still there. I have my friends working for many years. Okay, uh,
yes, sir.
work-life balance will be there. It depends on how much you're dedicating to the work and how much time you are going to spend for yourself. Always
Yes,
there,
sir.
but in India it is little bit less in PD for PD engineers. DFT and verification, okay, it's good.
Okay, sir. Thank you, sir.
Right. Thank you. So yeah, I think I'll hand it over to Yusuf. Yusuf will show the VLSI DFT course curriculum. What are the things in this? Okay.
Is
Might
my
yes, screen visible. Yes.
screen?
Yes. So everyone, this is a DFT course that Yusuf is going to show, and this is the subtopics that you are going to learn. I think as a beginner, you might not know what is what. Okay, you will be learning these modules part of the course structure for 4 months course structure. Okay, right. So can I hand it over to Yusuf? Everyone, any no technical questions for me?
Yes, sir.
Yep.
Okay, sir.
Thank you, Yusuf. Please take over.
Yeah. So guys, hope you guys can see my screen, right? So this is about the curriculum. So module 1 will cover digital electronics, which includes logic gates, Boolean algebra, okay, combinational circuits, adders, subtractors, okay, sequential circuits, finite state machines. Then module 2 would be the Verilog, which will have all basic gates, adders and encoders, multiplexers, flip-flop, latches. Then we'll move to this main content, which is in a basic DFT. So introduction and basics of DFT. So and see, these everything will be taught to you with assignments and mock interviews. So after completion of each and every domain, you'll have assignments and mock interviews. Okay. So basics of DLD, overall VLSI flow, DFT flow at a high level, hardware elements. These are about introduction of DFT. Then in the module 4 would be the scan insertion. It is one of the important content of the DFT, which includes scan insertion, scan insertion types, internal scan, boundary scan, scan methodology, chaining balancing. Okay, scan input, DFT rules check. So then we'll move to this scan compression. Okay, so need for what is the need of compression, compressor, decompressors, and everything. Okay, so we'll move to this ATPG also. ATPG, we'll cover entire ATPG topic from the basics. What is ATPG? Basic flow, inputs. Okay, LOS, LOC, and what is OCC? Advantages, disadvantages of their internal structures and simulations. If I'm not wrong, there are many very less institutions which will go with the simulations that do with the practical mode. Okay. And along with these are the, so we'll go with BIS technologies as well, which is very much required in current industry. We'll go with the introduction to M-based, like in BIS scan and L-based. These all is part of your training part. As I told earlier, right? Okay. These all concepts will be explained with examples, and after every completion of every module, you will have assignments and mock interview.